Oh, there we go. Hello and good day, Algebra. We are starting Unit 3 today, which is a major shift from what we did in Units 1 and 2. And Unit 1 was more of a, kind of welcome back to math thing, a lot of review stuff, okay? Unit 2 was all about exponent rules. Unit 3, we're going to shift our thinking to graphing, okay? Graphing. And we're going to start, you can do this if you want to jot these notes down on the back side of this page or the back side of the previous page. I only make these single-sided so you have these extra note areas because sometimes I do things that's not on the actual sheet itself. So talking about graph, where have you used graphs before, and in what context have you used graphs before? And if you tell me we've graphed equations, okay, but tell me a little bit more about that, like the context of when you graphed them, why you graphed them, what you were doing. Kylie. Okay, tell me more. Okay. She was saying if you did like a word problem, you're trying to figure out who made the most cookies for something. Jack, you had your hand up too.
I used it on my homework.
On your homework, how? Because you were told to graph an equation on your homework?
Yeah.
Excellent. That's following directions. That's an important skill. Good. Claire.
There's like the dot thing where you get the coordinates and you'd have to put a dot and then there'd be another dot.
Sure, plotting points, that's all part of graphing as well. Arlene?
With equations that are like y equals something with x.
Okay, so graphing on Khan Academy, practice work. I'm thinking kind of more in the context of like science. Have you ever graphed something in science? What did you graph? Yesterday, Long John, tell me more. The Punnett squares. Okay. Oh, all right. Catherine? Warnings for each of you. Kind of like the Punnett square? Okay, probability. You used kind of a chart or a graph for that. How about graphing data? Have you ever graphed data before, plotted points? Okay. I mean, maybe you've used this in the context, or maybe you haven't, but if you've got a coordinate plane here, right? And I'm not quite sure of your familiarity with the coordinate plane. Hopefully you've used all four quadrants. Usually when you graph data, you're kind of stuck in that upper right one because your data is usually all positive. But the other three quadrants are there and we will use them. But maybe you're plotting like how high an airplane is off the ground as it travels, right? So maybe you have, wait, time starts with the T, not an S. Time and height, okay? So at 0 seconds, it makes sense the plane's still on the ground, right? Because it hasn't taken off yet. It's still sitting there, okay? Once it starts to move and it starts to take off, maybe after, 5 seconds, how high do you think a plane is after five seconds? 500? Think so? 5 feet, 5 seconds, 5 feet, maybe. We'll just go 20. Maybe it's a small passenger plane, not like a big, F-150. That's a truck. I don't know. Anyway, then after 10 seconds, it's picking up speed. Maybe it's 50 off the ground, and then after 20 seconds, it really takes off. It's 200, right? And so then you go to your corner plane and you plot these points. Here would be 0, 0. Here would be about 520. I'm just estimating here. The accuracy isn't all that important. 1050 would be maybe right there, and then 2200 is going to be way up there somewhere, right? Okay, and then you can connect these points if you wanted to kind of get the general trajectory of the plane, and there you've got a graph. Poorly made graph, but a graph. Okay, and what we're going to, yes, you have a question?
Are we going to learn
about vectors in geometry. Okay, hold. Hey, folks, those are the kinds of things that don't need to happen, especially when we are recording. Okay, you've got plenty of time to talk and do all that sort of stuff before announcements and while I'm getting ready. But when we are recording, my expectations are that we are productive and we don't have those side conversations. Right? Yes? All right. Vectors, geometry. So hold that thought for about a year and 5 months. Okay. So anyway, and we're not going to be focused today so much on making the graph, but we're going to be focused on something called domain and range. Okay, have you heard those words before in the context of graphing? Domain and range? Okay, so we've got two pieces of information here, right? We've got time passed, and we've got the height of the plane. Right? If someone were to ask you, how long did you watch this plane? You'd say, well, I watched it from 0 to 20 seconds. That would be the domain, okay? The x values of a graph are the domain. We'll go back to the sheet and we'll define it officially on the page. So if you don't want to write it down now it's okay. But if you care about how long you watch this plane, that's the domain. It's a piece of information of this graph. It's all the x values that were included here all the time. Okay? If you cared about the height, say, well, how high did the plane get? Like, what was its lowest? What was its highest? That's called the range. So today, our focus is going to be on looking at a relation, which we'll define that shortly also, and then determining what is the domain, the x values, and what is the range, the y values. And you really get a sense of why this matters when we've got actual data. Because you might care about how long it took the plane, to get to a certain height. Okay? You might just care about how high the plane got. Okay? But when you talk about those different pieces of data, domain and range, we're talking about either the x values or the y values. Following me so far? Okay. So let's get some official definitions up here. Okay? A relation is a collection of ordered pairs. A collection of ordered pairs. So whether those ordered pairs are in a function table, an XY table, input-output table, they're all the same. Whether it's on a graph, as you see, we've got two examples here. One's a line, one's a segment. All three of these examples here are relations. It's a collection of ordered pairs. Okay? Domain, all the x values of a relation. And the range, all the y values of a relation. Right? In context of our airplane example, the domain was the time, the range was the height. Okay? You've probably seen this word before, talking about mean, median, mode. Right? What's the range in that context there, Andrew? Right. Okay, what's the difference between your highest and your lowest value? So there's a little bit different context of a similar mathy word. Okay, so when it asks for the range, and you're talking about coordinate plane stuff, relations, it's talking about the y values of that relation. Got me? What's your question? Okay, if you're still confused in like 5 minutes, then ask. Okay, all right. So let's look at our three examples of relations here. We have an XY table, we have a line, and we have a segment. Okay? When you have an XY table, maybe you call it what did Mrs. Feynman call it? Function table? Okay. When you've got a function table, it's got the X values and the Y values clearly listed. So it's pretty easy to identify what the domain and the range is, right? What are the X values of that relation? What X values are included in that function table, Max? -10, -5, 2, 4, 0. Right? They're just listed right there for you. What X values? What is the domain of this table? Well, since the domain is the X values, they're just listed there. Okay? How about the range? Where's the range? Kylie? -3, 0, 8, 2, and -1. Again, simply listed. Okay? So of these three, the XY table is probably the most defined. I don't want to use the word easiest necessarily, but it's the most defined. They are simply listed, right? Then we get to a coordinate plane. And I've got two examples of what could be on a coordinate plane. One's a line, one's a segment. What's the difference between a line and a segment? Tying in some more geometry stuff today. Sophie.
A line can go on forever and a segment cannot.
Right, a line goes on forever. That's why it's called a number line, right? Because it's infinite in both directions. That's what these arrows show here. Whereas a segment has a beginning and an end. It can be measured. It's got a starting point and an ending point. Okay? And so if we look at this line, knowing that it goes on forever, and I ask you for the domain, what x values are included in this line? I mean, you can say, well, this line kind of starts at -4, so to speak. The x value, that's -6. The x value, -6, and it quote unquote ends, at like +3. That's what we can see the line covers. But knowing it goes on forever, it's going to continue going on to the left of -6 and to the right of +3. Is there an end to the domain of this line? No, every x value is going to be included at some point. Who remembers the mathematical symbol for everything or all or infinites? We saw it first in PO7 with equations. Crinkle. Yes. It's that double-stemmed R. Okay? And what this means is that everything on the x value, or on the x-axis, every x value is going to be included in this line because it goes on forever. Alex? Probably all would be a better word than everything. All would be better. But yes, that I would know what you mean. Okay? How about the range? What y values will be included in this line? I mean, we can see this line, quote unquote, starts at, it looks like, again, -6 on the y-axis, and then it goes all the way up to, +7. But again, because it's a line, it's going to continue to go below -6, and it's going to continue to rise and go above +7. So what's the range of this line, Kylie? Again, all reals. And I'll use the word all this time because I do think that's a little bit better than everything. Okay? So anytime you see a line, the domain and range are always all reals, or that all real solution symbol. Okay? Yeah. Okay. A segment, though, is a little bit different because a segment does not go on forever. So looking at the domain of this segment, what x values were studied here? What x values were recorded on this graph? Kind of where does it start on the x? What's our lowest x value? And then what's our highest x value? Catherine? Good. This segment goes, it contains all the, what are you doing? Why are you doing this? I don't want to do it. What? No, stop. Is my red marker's in timeout. We'll try blue. Blue works. Okay. On the x-axis, everything from -1 all the way to +5 is recorded. Okay? But that doesn't mean that I can simply put -1 and +5, right? Because I need everything in between, right? It also doesn't mean that I can put -1, 0, 1, 2, 3, 4, and 5. Because what am I missing? Are those the only x values that this segment shows? No. What other x values does this segment show? Yeah, all the fractions, all the decimals, 1.5, 2.3, 1, 8, 6, 9, right? All those values in between these integers are also part of this segment. And obviously, we're not going to be able to write all those decimal values and fraction values. It take forever, right? So instead, the domain is -1 to 5. Okay? Everything in between -1 and 5. Yes, sir. Is that a hand up? No. Okay. Now we look at the range and what y values are recorded in this segment. What's the lowest y value? What's the highest y value? Burgess.
Oh, what is the lowest?
Yeah.
7.
All right. Our y values go from 1 to 7. So what am I going to write here? Just 1 and 7 or 1, 2, 3, 4, 5, 6, 7? Alex? 1 through 7. Okay. All right. Doing okay? Questions? Long John? Good? Yeah? Okay. So that's pretty much it. Okay. You'll see this notation down here. We'll get to that in just a little bit. That is essentially another way to write what I wrote here, this arrow thing. I reordered the numbers of the objectives this year. I don't know why, but I just felt like it fit better. And there's an objective that we talk about this notation, but I moved it to the end of the year versus the beginning. So that's why this is here. I just forgot to change it. So don't worry about that. But anyway, anything else? Okay. So looking at the practice here, says make an XY table or graph with the given domain and range. What's this going to be? Is this going to be an XY table or a function table, or is it going to be a graph? Kylie? It's going to be a function table, an XY table. Why? What about the way that is presented to you tells you it's going to be a function table rather than a graph? Beckman? What's that? It gives you all the numbers and lists them out, right? It says the domain, which are the x values, is specifically -4, then -1, then 6, then 0, then 2. Right? They're explicitly listed there. The y values that were tested or that were found or that are being used here, 3, -4, 6, 10, and -1. Right? Yes, Alex. You should put them in the order that they are presented to you. Yes. Yes. Okay. That next one, and again, I briefly mentioned that notation here. This essentially is the same thing as what we wrote up above there, -3 to 5 and 2 to 4. Okay. That's just a different way to write it, so don't be thrown off by it. What this means here is that x is between -3 and 5, or y is between 2 and 4. Okay, it's kind of the same thing that we set up above, and the same thing that we said this notation represents here. Okay, so this one's going to be a graph, and it's going to be a line or a segment. Segment. It's got a beginning and it has an end. Okay, so we're going to draw our coordinate plane here. We get to freehand it. Okay, it doesn't have to be perfect. How are we going to get the ordered pairs for this? How are we going to get a domain of -3 to 5 and a range of 2 to 4? Kylie, what do you think? Is my red still in timeout? My red is still in timeout. We'll go to blue. Okay. So Kylie's saying if we take our first set of numbers, like the low on each range here, I shouldn't use the word range, the low on each, I don't know, thing. That's not very mathematical. But this can give us the ordered pair -3, 2. Right? We are taking the low end of the domain and the low end of the range, And so we can plot that point, -3, 2. Again, just an estimate there. And then we take the high end also. Our highest domain, our highest x is 5, our highest range, our highest y is 4. So the other ordered pair that we can get here is 5, 4, which again, just estimate that, okay, about there. And if we connect these points with a segment, this is -3 here, this was 5 here, this was 2 here, this was 4 there. Do we have a segment that goes from -3 to 5 on the x-axis? Yes. And does it go from 2 to 4 on the y-axis? Yes. Okay. The other way to do this, you can also take the low of 1. My red is acting like a mouse right now. We'll go to black. You can also take the low of 1 and the high of the other, giving us the order pair -3, 4, which essentially is going to give you an X picture on the graph, right? And then 5, 2. Okay? So you can either go vertically to get your two ordered pairs, like I've done in blue, or you can go diagonally to get your ordered pairs, like I did in black. You don't need them both. You only need one of them. So either the low of both and the high of both, or go low, high, and low, high. You can get another segment there. Yeah?
Is there like a better way? Is that like one is the more correct way? Or
No, they are both just as correct. Because both of them go from -3 to +5 on x and 2 to 4 on y. Yes, sir? Yes, you can do one of them. You don't need them both. Okay? And then this question here, we kind of already answered it. How do you know if the relation is best represented as a table or a graph? Max?
If it tells you the exact number.
Right. If the domain and the range are listed, okay, it's going to be a table. If the domain and the range are presented to you like in between something, okay, it's got its beginning and an end, it's going to be a graph. Okay. The second page is your homework, which is going to be due tomorrow. And it's similar to what we did on the end of this page. Is this only one more page? Yeah, there we go. So this first one, make an XY table or graph with a given domain and the range. What's this one going to be? Function table or graph? Table. What's this one going to be? Function table or graph? Graph. And remember, this is the same thing as saying, in between 2 and 4 and in between 1 and 5. And you can either go vertically to get those ordered pairs, take the low of each of them, like we did in blue on the first page, or you can go diagonally, go the low-high method, and that will give you a segment as well. Okay? Going further down the page, at the bottom it says, when looking at a relation on the corner plane, how can you tell the difference between a segment and a line? And then what is the domain and range of a line? You don't have any lines to make on the back here. We focus on only those tables and the segments, but I don't want to forget about the lines. So you have a couple questions on the bottom as well. What is the domain and range of any line? Because it goes on forever in both directions. Anything, right? All or everything, that all real solutions, pretty fun to make, okay? Any of these you want to do together? We usually go over at least one, but Beckman? No? Do we like graphing so far better than powers? Yeah. Powers are pretty fun. Powers are fun. All right. This homework is going to be due, what day is today? Wednesday, due tomorrow. You also have con due tomorrow night, Max?
Do you just have to write out like all the numbers on the plane or just like the numbers that show where it's marked?
just the numbers that show. So like, are you doing the first one or the second one?
Yeah.
So if you're doing 2, 1, and 4, 5, if you choose to make this by going low, low, and high, high, on your coordinate plane, you can estimate kind of where 2, 1 is going to be about right there. You just mark that 2, 1. And then 4, 5, estimate what that's going to be maybe right about there. So here's 4, here's 5, and you make your segment there.
Yeah, that's what
Yeah, that is perfect. Okay. One thing I saw in the entrance exam for plotting points, some of you were getting your x and your y axis kind of confused a little bit. It's called an ordered pair because they're always given to you in the same order. The x value is always provided first. The y value always comes second. The x-axis is always the horizontal. The y-axis is always the vertical. Some of you were kind of just getting those backwards. Okay, so pay attention to that as well. All right, questions, comments, concerns, complaints, comments, congratulations, criticisms. For what? Well, congrats to you too for being a, yeah, you're welcome. All right, that's how you math, folks.